Okay, I wanted to do another video about unordered partitions, particularly when you're dealing with the case where you have even partitions that you're dealing with or uneven partitions that you're dealing with, because there's a big difference. And I want to kind of illustrate this difference by doing two examples. So the first example, I want to partition a set with four elements, say A, B, C, D, and I want two groups of two each. Okay, and this is a simple enough example that we could actually list out the partitions here before we would think about how to calculate it. Okay, so one way that I could do this, one partition I could do, I could partition off AB, and then I could also, that would leave me with CD. I'm going to go ahead and box that. That's going to be one way, okay? And then note, it doesn't matter whether I'm doing, AB or BA. It's just that I have A along with B in one partition, and then I have C with D in another partition. And then here I'm not also caring whether my partition of AB goes first or second. All I care is that it's partitioned off, okay? Another one that I could do I could partition off A, C, and then I would be left with B, D. Again, I don't care whether my partition of AC goes first or second. And then the last one that I could do would be A, D. And then I would be left with B, C. Okay? And those are my three partitions that I could do, two groups of two for four objects in our example A, B, C, D. Okay, and if you're familiar with any sort of partitioning like this, this could be done by 4 factorial. That's the total number of objects we have. I'm doing groups of 2, so 2 factorial. I have 2 of those groups, so squared. I also don't care about the order of my groups, so I also want to divide by 2 factorial. Okay? 4 factorial is 24. 2 factorial is 2. Squared would be 4, and then times 2. And then that would get me down to 3 ways, which is what we got. Okay? Now what I want to do is do the same thing here. I'm going to be partitioning off A, B, C, D, and I want one group of 2, and then I want 2 of just 1. Okay? I'm gonna list them all out, and then I'm gonna try to come up with a formula. I'm gonna show you the kind of maybe the right way to do the formula and maybe the wrong way to do the formula. So first, let's just list them all out. So one way I could do this I would do AB. So that's my group of 2, and then I would be left with a singleton of C and a singleton of D. Okay? Next, I could do A with C. Then we would be having the B and the D all on their own. I could do A, D. Then I would have the B and the C on their own. Okay, and there's a few more. I could do B, C. Then I would be left with A and D on their own. I could do BD for my group of 2, be left with A and C on their own. And lastly, I could do CD for the group of 2, and then I would be left with A and B in their group all by themselves. Okay, so there are 6 ways. Okay, look at it for a second, see if you could figure out another way. There's not, just those 6. And now I want to think about the right way first to maybe formulate how we could calculate this. Okay, so first I would say that we have a total of 4 objects to order. I have one group of 2 objects that I'm not distinguishing the order of, so that would be 2 factorial. And then I have my singletons. Normally I don't write 1 factorial, but I will in this case. Okay? Now the right way here would be I have 2 groups that I can't tell the difference of. Okay? And I have one that I can tell the difference of, namely my group of 2. Even though I'm not necessarily saying, making a distinguishing between these 3 groups, one group of 2 and then 2 just of 1, I'm actually distinguishing it because I made one group of 2. So in this case, I only have 2 groups that I can't distinguish from, so I also need to divide by 2 factorial, okay? And then that would give me 6 ways. I'm going to change my color, and I'm going to talk about the wrong way to formulate this, okay? So maybe the wrong way would be this is an unordered partition. I'm not necessarily making a distinction between my 3 groups. So it'd have the 2 factorial, the 1 factorial, then the 1 factorial. And then maybe now I would be thinking, hey, I have 3 groups that I'm not making a distinguishing between, so I'll divide by 3 factorial. However, if I did that, that would give me 2. Uh-oh. I came up with a total of 6 ways, not 2 ways to make this partition. So that's maybe the key that I want to drive home here. If you're considering that your groups, that you're not putting any emphasis on any of them, that you're not distinguishing between any groups, unless the groups are even, you can't make that assumption. Okay. So here I can assume that I can't distinguish between my 2 groups of 1. However, I can't for my group of 2. And let's do another example of this, but kind of show where this kind of really falls apart. Okay, so A, B, C. It's a simpler example, and I want to think about one group of 2, and then we'll have a 1 of just 1, and then we can easily write this partition out. So we could have A, B, we would be left with C. We could have A, C, we would be left with B. And finally, we could have B, C, and then we would be left with A. Okay? So that's 3 ways. Okay? And that would match up with maybe any sort of previous discussion that we'd have. We have 3 total objects. I have one group of 2, and I have one group of 1. 3 factorial is 6 divided by 2 would give us 3. Okay, so that right there, everything matches up. Where everything maybe falls apart, so this is the wrong way. If I were to think to myself, well, I have 3 total objects, I have one group of 2 and I have one group of 1. I'm not distinguishing those two groups, so let's go ahead and divide by 2 factorial again. Okay? Well, if I did that, 6 factorial would be 6. 2 factorial is 2. 2 factorial is 2. So that would be 6 divided by 2 divided by 2, which would be 1.5. That's a big uh-oh. Okay? That does not work out at all. Okay? So again, when you're having indistinguishable groups or unordered groups, you can only assume that you can't distinguish between them if they have even groups. Okay. One last example here. I'm going to have 18 objects. I'm going to do 2 groups of 2. I'm going to do 2 groups of 3, and then I'm going to do 2 of 4. Okay? And so here I'm just gonna go straight to the formula. I have 18 total objects that I'm ordering. I have 2 groups of 2. So in these 2 groups, I don't care about the order of these 2 objects in them. So 2 factorial. I have 2 of them, so I'm going to square that. So I'm going to change the color there. Let's make it green. Okay, I have 2 of those groups, and I don't care about the order of those 2 groups, so I'll do 2 factorial. Go back to black. For my 2 groups of 3 each, so for those 2 groups, there's 3 objects in each one of those groups. I don't care about the order of them. But I have 2 of those groups, so I'm going to divide 2 factorial because I'm not distinguishing between those 2 groups. Finally, I have the 2 groups of 4 objects in them, 4 factorial. I have 2 objects in each I have 2 of those groups, so squared, but then I want to divide out 2 factorial because I'm not distinguishing between those 2 groups there. Okay, lot of numbers here. Also, big result. This would be 9,6,408,600,039. And then it gives us zeros at the ends, and so that's nice. Okay, so again, when you're dealing with unordered partitions, you can only consider them indistinguishable between the groups if the groups are even. Okay, so for this last example, I could only treat the 2 groups of 2 as indistinguishable, and I could only treat the 2 groups of 3 as indistinguishable, and the 2 groups of 4. However, you know, since some of the groups have 2, some of them have 3, some of them have 4, those end up being distinguishable between each other. Okay, so thanks for joining me for my video. Until next time, bye.